All right, welcome to The Explainer. Today we're diving into something that's supposed to be a total game changer for all you makers and tech heads out there, the Arduino UnoQ. So an Arduino that runs Linux, what could possibly go wrong? I mean, this is a board that's supposed to give you the classic Arduino simplicity, but with the brains of a tiny computer. The big question is, does the reality actually live up to the hype? Let's dig in and find out. Okay. First things first, let's break down what actually makes the UnoQ so special. At its core, it's got this hybrid architecture. You can think of it as having a dual brain.
So it's literally got two different kinds of processors working together. On one side, you've got the microcontroller, the MCU. Let's call that the fast brain. This is your classic Arduino stuff, right? It handles all those super precise real-time tasks like blinking LEDs, spinning motors, reading sensors. But then, on the other side, you've got the microprocessor, the MPU, the big brain. And this thing is a beast. It's powerful enough to run a full-blown operating system and tackle the heavy lifting, like AI, Python scripts, or even computer vision.
And a quick look at the hardware specs? Whoa! We're talking a quad-core CPU, 16 gigs of storage built right in, which means, yes, you can say goodbye to messing with SD cards, plus all the modern connectivity you'd expect, like dual-band Wi-Fi and Bluetooth. And the craziest part? They've packed all of that into the classic, familiar Uno form factor that everybody knows and loves. So, you've got all this incredible power packed into one little board. How does Arduino actually sell this thing? Well, their big focus is on simplicity. They're positioning it as this all-in-one, super easy-to-use toolbox.
And a huge piece of that promise is the software. Arduino is really pushing this new, unified development experience called the Arduino App Lab. The idea here is that you can seamlessly mix and match your classic Arduino sketches with Python scripts, even throw in some AI models, all in one place. No fuss, no friction. That's the dream anyway.
And they really emphasize how quick and painless the setup is supposed to be. I mean, the official FAQ says, and I quote, "No complicated configuration needed. You'll be up and running in minutes." So the pitch is simple. You plug it in, and you start making cool stuff. Doesn't matter if you're a total beginner or a seasoned pro.
Okay, so that's the promise. Up and running in minutes. But what happens when the rubber meets the road? Let's take a look at what an early user actually went through, because this is where things start to get a little messy.
And yeah, this is where the story takes a sharp turn. Early adopters, like YouTuber Hamid Adafuya, quickly discovered that the out-of-the-box experience was, well, not quite as advertised. As he put it, he encountered some pain. And trust me, that pain was very real. So instead of just plugging it in and going, it turned into this whole technical ordeal. First, you had to download 2 different tools, one of which was a command line utility. Then, and this is the wild part, you had to physically find and short 2 specific pins on the board with a jumper wire, which, by the way, they didn't even include in the box. All of that just to force the board into an update mode so you could manually flash the firmware. From a command prompt, seriously. And you can just hear the frustration in his voice when he says this. It's just disbelief. This just perfectly captures that huge gap between the promise of up and running in minutes and the actual nitty-gritty reality of getting this board to even turn on properly for the first time. So, after about half an hour of downloading tools, messing with pins, running command line updates, and a few restarts, the board was finally ready to go. He described the whole thing as janky and crazy, which leads to the million-dollar question, was all that pain and suffering even worth it? And just when you think this is a story about frustration, it completely flips. Because once you push through that painful setup, you finally get to see what this dual brain board can really do. And oh man, it's something else. Okay, so check this out. This is the phenomenal payoff. The big brain, the microprocessor, is running a full-on Debian Linux desktop. Not just that, it's playing a YouTube video on an external monitor. And while all of that is happening, the fast brain, the microcontroller, is simultaneously and completely independently running a classic Arduino sketch, just blinking away on the built-in LED matrix. This right here is the whole point. The 2 brains working in perfect harmony. And you can see it right here. All that earlier frustration just vanishes. It's replaced by pure, genuine amazement. He's just blown away by what this single, tiny board is pulling off. This is that aha moment, the magic moment where you see the incredible potential. And get this, it's not just powerful, it's efficient. While it's juggling a desktop OS, a YouTube video, and a real-time sketch, the board is running cooler than a Raspberry Pi 5 that's just sitting there, doing nothing. I mean, think about that. For embedded projects where heat is a huge concern, that is an absolute game changer.
So, let's bring it all home. What's the final verdict here? Is the Arduino UnoQ the all-in-one toolbox you've been waiting for? Well, like with any tool, it really depends on the job.
If you look at the Uno R4 versus the UnoQ, the difference is night and day. The R4 is your classic Arduino, a pure microcontroller. It's simple, it's reliable, it's perfect for those hardware-focused projects. But the UnoQ? That's a whole different beast. It's this powerful hybrid machine. It's for those really ambitious projects where you need both that precise, real-time control and the muscle for things like AI, computer vision, or even just running as a standalone little computer.
So to wrap it up, the UnoQ is an immensely powerful tool. No question about it. It absolutely delivers on the performance promise. But, and it's a big but, that early adopter setup is a real challenge. That promise of plug-and-play simplicity, it feels like it's still a few firmware updates away from being a reality.
So is this messy, powerful board the future of making? It really does bridge this massive gap we've had for years between simple microcontrollers on one end and full-on computers like the Raspberry Pi on the other. It's creating this entirely new category, and that leaves us with one big, exciting question. When you put a tool this powerful and this flexible into the hands of makers, hackers, and creators, what kind of incredible